So today I'll be talking about the nanosatellite IoT constellation program by international collaboration, which I'm sure many of you already know about. And so I'll try to explain a little bit about the current status and also the next steps of the program. So first of all, I'd like to talk about the genesis of this program. So what is the background and what are the main objectives that we're focusing on in this program? So there are two basic ingredients that went into this program. One is the 20+ year heritage of UNISEC. So UNISEC has a network of in Japan of 41 universities and has launched 60 satellites. So very long heritage in small satellite development. And in parallel, we have a very important other ingredient, which is the UNISEC-Global community. So points of contacts in almost 70 countries and local chapters in around 30 countries around the world. So by combining these two ingredients, we propose the nanosatellite constellation program. So this is although it's called nanosatellite, actually it's quite a flexible program, and participants don't necessarily have to develop a satellite. So they can develop a satellite or focus on ground segments or focus on specific subsystems. So I'll explain more in the remainder of the presentation. So in terms of satellite development, what we aim to achieve is to jointly design a satellite bus, so nanosatellite class between 3 and 6U, and there will be some online guidance for that. As I mentioned, countries don't have to develop satellites, but if they wish to, there's the option to do so. If a country does wish to develop a satellite, then they will have to do so with their own funding, and we will provide some support for seeking joint international funding if the need is there. Regarding the specific missions, since we are doing a constellation, we would like to have one common mission payload between all satellites. And in parallel, if countries wish to develop their own satellites, of course, it's possible to have specific mission payloads of their choice. And for the common mission, we have decided to focus on an IoT type mission. So in the next few slides, I'll explain a bit more about actually what is IoT, and then why did we decide to choose this for our common mission. So I think many of you already know what IoT is, but just in case, I'd like to give a small recap. So essentially, IoT refers to smart and connected objects. That's the maybe simplest definition. And within this concept, we have the idea of monitoring different assets. We're collecting data potentially on the environment around those assets, maybe doing some tracking. And overall, the process will be quite highly automated. And thanks to these activities, we can reduce operational costs for data collection, and we can conduct some optimization and improve reliability. So by the way, this is taken from a paper on satellite IoT, which is open access, and it provides quite a nice overview of this topic. So if you're interested, I recommend reading this paper. So below, I've just put a few activities that we may expect to encounter in IoT for agriculture, for example. So let's say that you are operating some agricultural land and you want to monitor your assets on that land. So for example, you may install a transmitter and sensor on your machinery to monitor the health. You may also wish to install some sensors in the ground to monitor humidity and temperature, for example. And this information could be used for predicting and monitoring disasters like drought or flood. And you may also be monitoring trespassers who enter your facilities. So this data will be transmitted to some kind of ground infrastructure, and it will finally be relayed to you where you can make decisions based on that data. So if we rely only on ground infrastructure, there may be some limitations. So for example, if we are trying to access data in remote areas, it may be quite costly or difficult to install the terrestrial communication. And similarly, if we want to communicate with sensors which are distributed over a very wide area, it may also require large cost, or it may be quite a complicated process. So this is where satellite IoT can come into the picture, because satellites provide access to remote geographical areas where terrestrial networks may not be compatible, and they may also offer more cost-effective solutions for those types of applications. So when we involve satellites, we are basically doing what is also called store and forward. So we're collecting data. This is the uplink part. So the data may be uplinked directly from the point of data collection using a transmitter attached to the sensor, or maybe it will be transmitted via an intermediate hub. And then once the satellite passes over the ground station, we are able to collect various different types of data at the same time and use them for making decisions for our field, for example, in this case, for our agricultural business. So IoT presents various benefits, IoT satellites present various benefits, including low power transmission. So we need less than 1 watt of radio frequency power in most cases to perform this data transmission. Although the data rate is typically limited, often this is enough to gain valuable ground information. As we saw on previous slide, we can gain access to data in remote areas with limited ground infrastructure. This type of mission is compatible with quite a simple bus on the satellite side because we're only using quite limited data rate. And one other advantage is that even after we launch the satellite, we can continue to improve the ground sensors, we can add new ones, we can collect new types of data continuously, even after launch. So why are we focusing on a constellation? Why can't we do this with a single satellite? So if we use one satellite, you can imagine that if it fails, the mission is basically over. Similarly, if we only have one satellite, we can only access the satellite for limited durations every day. So for example, around 40 minutes typically. We will also have a delay for downlinking the data. However, if we use a constellation, we have backups in case of failure. We can use other satellites if one no longer works. We have longer communication service time and potentially even continuous communication service if we have enough satellites. The data downlink delay can be reduced. And perhaps most importantly, as a university community, by joining a constellation program, instead of having just a single satellite, we can access all the satellites in the constellation. So that's clearly quite an attractive benefit from a university perspective. So in summary, by using and by accessing an IoT constellation, we can combine solving a local problem, which will meet our specific needs, with together solving a global problem by combining our different data in different locations. So now I'd like to say a few more about potential use cases that can be considered for IoT missions. So these are some examples of local use cases that may be considered among our UNISEC-Global community. For example, drought detection and monitoring, oil spill detection, wildlife monitoring for these moving assets, flood detection and monitoring, landslide monitoring, and so on. So in other words, IoT missions can be used to address various problems in different countries, which are likely to appeal to different governments. And in order to design more specific missions for these different cases, we have to think about what types of information we need to collect, as I'll explain later in the presentation. So in parallel with these local use cases, by combining the data from different satellites and from different locations, we can begin to think about addressing global challenges. So at present, there are different kind of problems we're facing that are actually common around the world, including global warming, deforestation, desertification, sea level rise, earthquakes, air pollution, and so on. So in this case, as a university community, we're in quite a good position to contribute to solving such challenges if we are able to combine our knowledge through this type of IoT constellation mission. And again, in order to address these types of problems, we have to think in more detail about what type of information we need to collect. So that was a short introduction to the IoT, the background of satellite IoT. And now I'd like to explain in more detail the structure of the IoT constellation program that is being developed by UNISEC-Global. So essentially, there are four steps that we have been working on so far. So step 4 will begin in the near future, and we've been focusing so far on these 3 steps. The program kicked off in December 2024, and we are now here today, so in the middle of step 3. And in the next few slides, I'll talk in more detail about these first 3 steps, and details about step 4 will be announced in the near future. So the first step of the program was to think about a basic IoT mission proposal. So we asked participants to develop two aspects. So first aspect is IoT mission overview. In other words, the use case for the IoT mission. In other words, what type of sensor data do we need? Who will be using the data? Who's the end user? What are the objectives? And how will this mission contribute to society? And in parallel, we also asked participants to think about what are the more specific requirements for the IoT system. So for example, how often do we need the data? How much data do we need? How much delay is permissible? Do we need the data within the next few hours, or can we allow a few days of delay? How many sensors do we need? And so on. So by the end of step 1, we have an idea of what would be the use case and some basic requirements in terms of data. The second step that we asked participants to think about is frequency information for uplink. Specifically, we asked participants to think about specific low-power radio stations. So I'm sure many of you already know about these, but the idea is that using a specific frequency band, and provided that the transmission power is below a certain threshold, we don't need a license for each transmitter, and we can simply obtain a technical compliance certification that can be used for these multiple transmitters. So we asked participants to conduct research on each country. What are the frequency bands and power limits associated with such stations? And then in step 3, we focused on the stakeholders who may be involved in supporting the IoT missions in participants' countries, focusing on their needs, expectations, and advice regarding the IoT mission. So for example, types of stakeholders include the data end users, ground segment developers who may have experience of already deploying distributed sensors, telecommunications regulators, security providers. So for example, if we're going to deploy infrastructure or equipment in remote areas, we have to think about the risk of theft. So receiving advice on such aspects is quite important. We also consider sponsors, so who's going to provide funding for the project, and finally media. And in parallel with the stakeholder consultation, we also encourage participants to consider cost estimation. So at this stage, a rough estimation is okay. And we ask participants to think about, for the ground segment, what is the expected total cost of the mission? And alongside this, what is the amount that the country's government can likely afford for tackling that specific social issue? So for example, if the issue is air pollution, roughly speaking, how much budget is the government going to allocate to tackling air pollution as a whole? And based on that budget, do we think that IoT is going to be a realistic way to address that challenge? So that was a short introduction to the structure of the program, and now I'll say a few words about the current status. So we're very happy to have received proposals from 20 countries around the world. So we're very excited and optimistic about the next steps based on this nice engagement. And as far as mission proposals and objectives are concerned, here we can see some keywords that have emerged from the proposals in terms of sensor data, objectives, and end users. So 2 key points, really. So first key point is we can see a very wide range of different objectives, but at the same time, there's some important overlap. So again, this comes back to this idea of the efficiency of collaborating on this type of constellation program. So we have some recurring sensors, for example, which focus on temperature or location, soil, and water. So even on the ground segment, we see that there's some quite important ground or room for collaboration between different participants in this program. In terms of objectives, you can see obviously monitoring is going to be one of the main ones. And more specifically, we have keywords like emergency, we have health, and so on. So we can see that there are some common objectives that we can potentially collaborate on through this program. And regarding end users, we see that the government and ministries are one of the key ones. We also see that researchers and education are another main focus, and private and corporate players are also involved. So we see this balance of local objectives and items that can be addressed in each country with some overlap between our different members that can be kind of addressed on a global level by collaborating within the Constellation program. So we have been lucky to already have a few presentations 2 months ago by IoT program participants from many different countries. And today we're excited to be having 3 additional presentations from Egypt, Nigeria, and Tunisia. And we're also very grateful to have with us today 2 companies working in satellite IoT or IoT who will be sharing insights on their activities. So that's all from me. And just like to say in closing that if you have not yet submitted a proposal, it's possible to do so. So if you're interested, please continue to give it further thought and we'll welcome your submission. Thank you.